Today, we are diving deep into the hidden world of the most common operating system on the planet, Microsoft Windows. I mean, we use it every single day, but what is actually going on under the hood?
It seems so simple, right? You click, a program opens. But believe me, underneath that one simple action is this incredible high-speed ballet of coordination. It's a system designed from the ground up to keep your computer from just descending into total chaos.
Just try to imagine the chaos for a second. Before modern operating systems, this was the absolute nightmare that developers had to live with. Imagine you're writing an app, and you have to write unique, special code for every single printer, every model of mouse, every graphics card out there. It made software incredibly unstable and just wildly expensive to make. There had to be a better way for all our apps and all our hardware to talk to each other. And that's where the modern operating system comes in. To solve all that chaos, it was designed from the ground up to do two absolutely critical jobs: to act as a master translator and a traffic cop for your computer. So, okay, what does that actually mean? Well, think of it like this. An operating system is the program that acts as that master translator between all your apps and your hardware. And at the same time, it's the traffic cop that's managing all those competing programs that are trying to run at once. Now, this whole idea didn't just pop up overnight. For Windows, it was a pretty gradual evolution. You know, the early versions were really just these graphical shells that sat on top of an older system called MS-DOS. The real game changer, the big one, was Windows NT. That's new technology, back in 1993. This was a completely new OS, built from scratch for stability, and its core architecture is still the foundation of the Windows you're using right now. Okay, so the single most important design feature in Windows, the thing that makes everything else possible, is this really strict separation of powers. And for our explainer here, let's think of it as an upstairs/downstairs model. So here's how that upstairs-downstairs thing works. All of your applications, your web browser, your games, your word processor, they all live upstairs in what's called user mode. You can think of them like tenants in an apartment building. They have limited privileges. Meanwhile, the core of the operating system, the really important stuff, lives downstairs in the super protected kernel mode, and it has total, unrestricted access to all of the computer's hardware. And this right here is why that separation is so brilliant, so important. It basically acts as a firewall. It protects all that critical OS data from buggy or even malicious applications. It stops programs from just directly messing with your hardware, and, maybe most importantly for us every day, it gives the system stability. So when an app crashes upstairs in user mode, it doesn't take the whole system down with it. So let's follow a really simple action, like saving a file. Your app, which is living upstairs, it can't talk to the hard drive directly. No way. Instead, it has to make a formal, polite request using something called an API. That's an application programming interface. Think of it like ringing a doorbell. That request then crosses the protected boundary, it goes downstairs into kernel mode, and the trusted OS safely takes care of the request. Okay, so that's the whole master translator job, protecting the system's core. Now let's switch gears and look at the traffic cop role, which is what creates that seamless illusion that your computer is doing a dozen things all at once. So anytime you launch a program, the operating system creates something called a process. The easiest way to think of a process is like a dedicated, isolated container just for that application. It holds everything the program needs to run, all its memory, file access, you name it. Now, inside that process container, you have one or more threads. And the thread is the actual worker. It's the part of the program that's executing the instructions, doing the work. A really simple program might just have one thread, but something complex like your web browser, it could have dozens, all handling different tasks at the exact same time. You know, early versions of Windows use this system called cooperative multitasking, and it basically just trusted every program to be a good citizen and voluntarily give up its turn on the processor. As you can probably guess, one greedy or buggy program could just hijack everything and freeze the whole computer. Modern Windows, thankfully, uses preemptive multitasking. And in this system, the OS is a strict traffic cop. It forcibly interrupts threads and gives each one a tiny little slice of time on the processor. This makes sure that no single program can just hog all the resources. So kernel mode, preemptive multitasking. These sound like really abstract concepts, right? So why should you even care? Well, the answer is simple, because they directly and profoundly impact your everyday experience every single time you use your computer. This whole architecture is the reason why, when your web browser crashes, you don't get that dreaded blue screen of death anymore. That crash is safely contained upstairs in user mode. It's why malware can't just easily take over your webcam. It has to ask the kernel first. And it's why your mouse cursor still moves so smoothly, even when your computer is in the middle of rendering a huge video file. The OS is constantly preemptively scheduling everything to keep things feeling responsive.
But this fundamental architecture of protection and scheduling, it's not static. It's constantly evolving, especially as the role of the operating system expands way beyond just the personal computer on your desk.
Yeah, starting with Windows 10, Microsoft really shifted its whole philosophy. They moved away from these big, distinct version releases every few years. Now, they treat Windows as a service, something that's constantly being updated and improved in the background, kind of like a website or an app on your phone. And what's amazing, what's really cool, is that this is all built on a single shared platform called OneCore. Now, what this means is that the fundamental heart of Windows, that very same protected kernel we've been talking about this whole time, now beats inside of everything from your desktop PC to your Xbox to augmented reality headsets and even teeny tiny smart devices. So the core jobs of being a translator and a traffic cop, they're always going to be there. But as the OS becomes this sort of invisible fabric that connects all of our technology, the real question becomes, what new roles will it need to learn? What new challenges will our master translator and traffic cop need to tackle next? Well, that's the next chapter in the story of the operating system, and it's a story that we're all going to be a part of.